talk about the distributive property. So first of all, pencils down, rewrite using the distributive property. So this is saying that I have 6 quantity times the quantity 10 plus 3, correct? So just like we talked about with that Happy Meal distribution, right? I'm going to distribute, well, let's go over our steps first. I'm going to come up with a plan. My plan is I'm going to distribute. Makes more sense when we've got a little bit more going on. Okay, so let's distribute. 6 times 10 is 60, and 6 times positive 3 is positive 18. What's 60 plus 18? 78. There's my answer. How many of you, raise your hand if you thought, well, couldn't she just add 10 plus 3?
Yeah.
Okay, well, let's look at the outcome of that. Good, I like that word. Good vocabulary. Let's rewrite this as 6 times the quantity 13. How many of you know how much 6 times 13 is? What do you think? How do you know that? Because we just did it. But if you were just to have 6 times 13, is 6 times 13 come to your head just like that? Really? You know your 13s by heart? I don't know my 13s by heart. But you know what I would do? In my head, I would say, how much is 6 times 10? 60. How much is 6 times 3? 18. Add them together, 78. Okay, moving on. Let's try this one now. It's the same method. How many of you know 5 times 75 just like that? What? So, if I don't know what 5 times 75 is, couldn't I come up with a plan and rewrite this as 5 times, what? How could I rewrite 75? What? I would write it 70 plus 5. What property did I just use? If I say 75 is actually 70 plus 5, what property is that? If I said 70 plus 5 equals 75, what property would that be?
Substitution.
Substitution. Right? Isn't substitution, say, substituting one thing for another? Isn't 75 also 70 plus 5? Right? Okay. So let's move on with this. Now, what can I do with this? Let's distribute. What's 5 times 70? Isn't it the same as 5 times 7 times 10? Isn't 70 7 times 10? So didn't I actually write 5 times 70 is 5 times 7 times 10? Am I right? Plus 5 times 5? What is 5 times 7 times 10? What's 5 times 7? What's 35 times 10? 350 plus 25, 375. What was this step? How do I go from here to here? What do these arrows mean? I distributed. The distributive property. And what did I do to go from here to here? Good job, guys. Substitution. And from here to here? Substitution. Okay. I'm going to start writing these out in abbreviations on the next one. All right, questions? All right, let's move on. Rewrite using the distributive property. Come up with a plan. Do you guys see a plan? Anything else other than distributing? I don't see anything else other than distributing. So that's what we're going to do. We're going to distribute that to everything inside of our grouping symbols. So I have 2m's is 2m, and 2n's is 2n. Distributive property. And that one's pretty much done. Correct? This means I have an m, and another m, and an n, and an n. Okay? Do I have 4 of them? Do I have 4 mn's? No. I have 2 McFlurries and 2 orders of nuggets. Can you combine 2 McFlurries and 2 orders of nuggets? I wouldn't want to, right? Okay. Rewrite using distributive property. I need it quiet, please. Rewrite using the distributive property. Let's come up with a plan. What do these 2 terms have in common? They both have x's. If I were to factor out an x from 12, what would I have left over? 12. And if I were to factor out an x from 7x, what would I have? 7. Now some of you may be saying, but they're like terms because you just added them from the very beginning. Well, I understand that, but sometimes you need to use the distributive property in this way, kind of like the inverse distributive property, because sometimes in more complicated problems we need to use it. So let's use it in problems that we already know the answer to. We all know that 12x's and 7x's make 19x's, right? But let's do it this way just so we can see how it works out. So now I have 12 plus 7 is 19, which was substitution. And now I'm going to say, well, I don't normally say x times 19. I normally say 19x's. What property was that? What property says instead of x times 19, I have 19 times x? No. Anybody know what property tells me, Johnny, what property tells me I can write x times 19 as 19 times x? What property tells me I can do that? Maybe Joshua can help you. No, distributive property doesn't tell me I can rewrite this. No. Associated means what? Associating with somebody new, right? Associating with somebody new? Yes. Commutative property. Well done. I can move, right? They can move places. Good job. So there's our answer. All right, pencils down. Let's come up with a plan. I want you guys to share with each other a plan on how to use the distributive property to solve 6 times 7 2/3. All right, let me give you a hint. If I were to say, we'll have our little side box over here to talk about. If I were to say, I need 1.5 cups of sugar to put into my Kool-Aid pitcher. Tell me verbally how you would measure that out. Raise your hand. Yes, sir. 1 cup and then another half of a cup. So that could be written 1 cup plus half of a cup. Right? Based on that, I want to see your plans now. All right, so using your whiteboards, I want to see the first step. I want to see 6 times 7 2/3, please. And so I need everybody to show me this step. 6 times the quantity, 7 2/3. Make sure you have that on your whiteboard. Now what's your next step? I've come up with a plan. I split up 7 2/3 to look like 7 plus 2/3. What property was that again? Going from 7 2/3 to 7 plus 2/3. I'm not distributing yet. I didn't move anything. Substitution. Good. That's right, substitution like that. All right, so now, what would be my next step? Distribute. Excellent. So show me the distributive step. 3, 2, 1. So if I distribute 6 times 7, and we're going to make sure that 6 gets distributed to the 7. Oops, it's under our distributive property right here. 6 times 7 plus 6 times 2/3. I'm going to rewrite this though. I think it's pretty safe to say that this is 42, correct? Some of you multiplied 6 times 2 is 12. 12 divided by 3 is 4. That's okay too. But when we've got big numbers, sometimes it's not easy to do that. So if I were to write this out, I would write it as, what is 6 factor in factor form? 6 over 1, or 3 times 2 over 1 times 2/3. Why in the world would Mrs. Muller write it like that? Yes, sir. Because 3 divided by 3, 3 in the numerator and 3 in the denominator are inverses of each other. Multiplicative inverses. Right? I would. Well, no, you don't have to put it on your whiteboard. So I'm now left with 42 plus 2 times 2 is 4 equals 46. And like I said, again, you may have already seen that you could have simplified that easier, right? But if we practice with the stuff that we know, then when we get to the stuff we don't know, it'll become easier to us if we've already practiced it. All right, let's move on. Questions before we move on? Let's do the next one. Come up with a plan. As soon as you come up with a plan with your shoulder partner, go ahead and write down your first step. All right, so I'm seeing lots of skipping steps. I saw a lot of this. You didn't do this quite correctly.
Oh, x equals 4? Oh.
But, although that is correct, does it help us enough? You know what? If you did it that way, then you would have to do this. Then, you just be doing this again, right? So let's not do that. Let's back up. Why are you saying, oh, it's just on a whiteboard? Okay. Let's start with the associative property. I'm going to associate 3x squared and negative x squared because they're both x squared. Associative property. Next, I'm going to say, oops. Next I'm going to say 3x squared and negative x squared have something in common. What do they have in common?
An x
Not just an x.
squared.
An x squared. If I were to factor out an x squared, what would be left over from 3x squared? 3. And if I were to factor out an x squared from negative x squared, what would be left over? Not just 1. Negative 1. If you said 0, x squared times 0 is 0x. We're not accounting for any x squared, right? There is exactly 1x squared. Actually, negative 1x squared there, right? Good. So that property would be what? When I factored out an x squared, I was using the distributive property, just in reverse, right? I was factoring out, instead of giving one to everybody, I took one from everybody, right? Does that make sense? Distributive property works both ways. You can give something to everybody, or you can take something away from everybody. Both of them are distributive property. All right, so now I'm going to say 5x plus x squared. 3 minus 1 is 2. What property did I just use? Substitution. Good. And what's my final step? Do I normally write things like this? How would I write it? I wouldn't say x squared 2 times. I would say 2x squared. What property is that? Alex, what property is that? I'm asking you for a specific reason. X squared 2 times is the same as 2x squared. What property is that? No. What did you say last time? Right? I'm moving. I'm moving the 2 in front of the x squared, right? Commutative property. Okay, question.
Yeah.
Yes, Joshua.
Confused now. I got lost after the first part.
You got lost after the first part. So right here,
Yeah.
do you understand that we were associating these two together?
Yeah, I got that.
Okay. Then I factored out an x squared from both because they both have x squared in common. It's the same thing as saying, let me change my color here. It's the same thing as saying 49 plus 56. If I were to factor out a 7 from 49, what would I have left? And a 7 from 56? So it's the same thing as saying 7 times 15. Or 7 times 10 plus 5, which would be what? 105. 70 plus 35. See how I just did that? I took a really, well, 49 plus 56 is not really that hard. But you see the steps of what I just did?
So what did you factor out of x squared?
I factored an x squared out.
You just took the whole thing out.
You know what kind of
Yeah.
confuses students? When there's nothing there. What if it was this? What would go here?
2. Oh, yeah.
See what I mean? It's confusing when you see it as just x squared. You think, well, what'd you do with it? It has an imaginary 1 in front of it.
All right.
You got it?
Yeah.
Good job. All right, let's move on. All right, pencils down for this one. Let's just work this one together. All right, so this is how I work translating algebraic expressions. So pencils down means I shouldn't hear you talking. Okay? Johnny, I need your full attention, please. Full attention, guys. Andrew, full attention. Okay, when you work with algebraic expressions and translating them, here is the key. The key is start with your variable. Don't try and skip around. Start with your variable. So let's read and find our variables. Translate into an algebraic expression and simplify. 5 times the difference of q, down to variable, squared, and r, another variable, plus 8 times the sum of 3q and 2r. That's where we start. Where are my variables? I'm seeing way too much shuffling. I need everybody's attention. So, let's reread this and see where we're going to begin. 5 times the difference of q squared and r. I've got a q and an r. What else do I have? Nothing else. I do not want to talk about any operations yet. What other things do I have? Plus 8 times the sum of 3q and 2r. I've got 3q and I've got 2r. That's where you start. Okay? Now let's go back and start underlining things, but we're going to work from variable out. So let's start here. Q squared and r. Q squared and r. So what am I going to do? Square the q. All right, we got that covered. Q squared and r. Now back up just a little bit. The difference of q squared and r. How do I write? See, I'm working backwards. How do I write the difference of q squared and r? Minus. Right? The difference between them. Let's back up a little bit more. 5 times the difference of q squared and r. How do I write 5 times? Like this? Why do I put a parentheses around it? Because it says, see why I work from here out? If I would have worked from here going, I might have written 5q squared minus r. And that wouldn't be correct, correct? Okay, let's do the same thing over here. So do I have all of that statement, 5 times the difference of q squared and r? Is that what that says? Perfect. Now let's go over here. 3q and 2r. What about 3q and 2r? The sum of 3q and 2r. There's the sum. What else? 8 times the sum of 3q and 2r. How do I write 8 times the sum of the two of them? Parentheses 8. And before that, plus. Plus what? Between the two. They're actually terms. This is a whole term because it's saying 5 times this quantity, and this is a term, 8 times this quantity. Correct? Let's rewrite. 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. Let's rewrite. Where am I going to start? No. 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 Where? No, no, no. Let me reword my question. Where am I going to start when I'm translating a sentence? With the variable. I'm going to start with the variable and work my way backwards. Okay, so let's finish this. So, I just translated the sentence. What's my first step? Let's come up with a plan. We need to do what? Distribute. So let's distribute. When I distribute, I get 5q squared minus 5r. Doesn't this say negative r? So 5 negative r's, isn't that negative 5r?
No, where'd you get negative r?
Because up here it says q squared and r, the difference between them. Isn't difference mean subtraction? If I say the difference between my two kids is 2 years, didn't I just subtract 8 from 6?
Yeah.
Right? Okay. Good question. Plus, whoa, that doesn't work real well. It's because I'm down here at the very, very bottom. All right, I'm going to have to move away from my microphone. Let's try that again. Okay, plus, I think my pen is dying on me. Yes, they can die. Battery. Right? It's a battery. There we go. Plus, 8 times 3q is 24q. Plus, 8 times 2 positive r's is 16 r's. It's a scribble. All right. What's my next step? So I just distributed. What's my next step? What am I going to do?
Combine like terms.
Okay, but before we combine, got to move things around, right? So I've got 5q squared. I've got another q over here, so we took care of him. Let's take care of this one. Plus 24q. Then I've got negative 5r and positive 16r. Which one do you want to put first? I don't want to put the negative first. You know what? It's going to complicate when we try and distribute. I'm going to put the positive one first and the negative one second. Exactly. Exactly right. So I just use what property? There it is. Commutative. Okay, now I'm going to group these two together right here, right? And these two can't be grouped because they're not the same thing. This is 3 squared This is 2. So let's just rewrite that. 5q squared plus 24q plus, what do these two have in common? They both have an r. Let's factor an r out. What are we left with? 16 minus 5. Do you see why I put the negative sign second now? What property was that? When I factored out an r, I took one from each one, right? Okay, 5q squared plus 24q plus, how many r's do we have? 16 minus 5 is 11 r's. What property is that? Substitution. Good job, guys. Go ahead and copy these down into your notes. Think about what you do as you copy the notes down.
Oh my God. 0.